Somu, you make your system mute. Somu. Okay. So we had covered up to chapter 23 till the character of salesman. The architecture is a salesman. He should be able to sell his plan among the members as well as among the other stakeholders. So he is the salesman. Then what he does, he works in a team. Here we will start today. So a team is a collection of software architects as well as developers, as well as, because it's a big team, 30-40 persons team. So one architect is difficult to manage, and a person having 11 skill set is difficult to obtain. So we get 2-3 junior level architects, then one principal architect. One principal architect, under him some junior level architects are there, and under junior level architects, different categories of developers work in a team. So it's a collection of the different architects, and they are stratified. Stratified means at different level. Someone in the upper level, someone in the medium level, someone in the lower level. So they are stratified. Stratified means they are placed in different level. Strata. Strata means level. Stratified. The team size fluctuates during the life of projects. There is no hard and fast rule that this should be the size of the team. So it fluctuates, it varies. One architect per 10 developers. It's not like that. One architect for 9 developers. 1 plus 9 is 10. So one architect, it's a little bit, I don't agree to this. 1 plus 9. So a team of 9. A team is supposed to be having to have maximum 9 persons. Supposed to be, but people don't follow strictly, but supposed to be 9. And 9 plus 1, who is the chief, called as the architect. So there should be 10 persons in that team. And in some places, one architect for 10 to 12 to 15 developers in later stages, but usually this is to be avoided. This is to be avoided. Don't add on developers if the problem is complex, because if you go on adding developers, the problem becomes more complex to handle them. To explain the problem, get the solution from them, it becomes more difficult. But in very rare cases, sometimes it gets extended to 12 to 15. But it should be avoided. It should be avoided. More number of persons do not help in bringing the solution. You try to get the solution with the number of people, whatever you had. In the worst case, you can increase the size. Okay. Architects may become subsystem development leads. They become the leader. They become the lead. They become the maintainer of a grand vision. They maintain whatever the vision they have. They maintain it. They bridge to central architecture team. This junior level architect, they work as a bridge to the higher level and the lower level. And when the job is over, they are shifted to other projects. They may be shifted to other projects after project's architecture is sufficiently stable. So that team, as I told, one is in the upper level architect. Under one architect, there are 9 developers. There are 9 developers. Just, I'm coming, just 1 minute. So what is the role of the team members in that team? So what they do, the chief helps to define the architecture. This is the job you have to do. They define it. The mental architectural integrity. Integrity means honesty of the software. How that type of connectivity among the components to be done honestly. Architectural integrity. Access technical risk associated with the design. What are the risks associated? They assess it. Assess. Assessments, evaluate. What are the risks? If I do this, then what type of problem I am going to face? They assess. They propose order and contents of development iterations. In which way they should do the iteration. This is fast or that is fast. They propose the order and contents. What is to be done? The contents. Coordinate and coexist with other teams. There will be different sub-teams. Had you been in Raurkela, then I would have explained in Blackboard how the sub-teams work. Assist in project management decisions. Assist in marketing in future product definition. So this is the role. This is the role of the architecture team. Then they define the architecture among the members. What are the major design major elements? Which are the major elements? System organization structure of the overall system. Structure means which one in the upper level, which one in the lower level. Mostly here the structure means mostly the class diagram. That is the structure chart. They explain it among themselves. The way major elements interact, which are the most important elements or classes, how do they interact, how the message passing works, what type of connectors work among themselves. They explain it among themselves. They define it and understand each other. Works with the system engineers and development teams. They work with the system engineers, means the hardware engineers and other team members who are associated with the development process. So what is this maintaining architectural integrity? Integrity means mostly integrate things honestly, in a very honest way. Following certain guidelines for design and programming. They help with reviews. They approve changes to interfaces. They approve changes to interfaces of major components. Any sort of changes occur, they have to first approve. Because subsequently somebody may complain, this thing has been done without approval. So keep everything in record that this component has been approved on this day, then subsequently changed on this day. This is the practice in industry. Whenever any component is identified to be developed, they keep record of it, keep record of any changes, any sort of changes they make, they keep record. Any sort of departure from guideline. Earlier this was the guideline, something change we made. So when did we made the change and why we made the change? They keep note of it. So that honesty is maintained. Nobody can do it as per his sweet will. And the architects are the final arbiter on aesthetic. Aesthetic means beautification, how beautifully you design the software. They are the final arbiter. Arbiter means decision maker. When there is any confusion or conflict, they take the decision. Assist change control board with resolving software problem. There is a board which approves any sort of changes. So that board is being assisted by the architect. This is the reason why we made some changes. So that control board approves in industry, this is in large industry, Whenever you join any big industry like Google or even Infosys, TCS, maybe they may be having this. They have a change control board where any sort of change in the design is first approved, and that approval process is being assisted by the architect of the team. Okay. Then they assess the technical risk assessments, evaluate any sort of risk in the future. They evaluate what are the risks. The team maintains a list of perceived risk. What are the future risks? If I do this, then whatever problem I am going to face. If I do this, what are the problems I am going to face? So they make a list of it. May propose exploratory studies of prototypes. They propose some sample. Do this sample, test this sample. Prototype means sample. They explore before implementing anything. They explore some samples and work on the sample to check up to what extent any risk is there or not. So they assess the risk. Then the order and content of the development iteration. This they fix up the order. Team determines the order and contents of the iteration based on selected scenario. What are the scenarios? Taking certain scenarios, selecting certain scenarios, selecting certain scenarios, they assess they fix up the order. If we go in this order, in this sequence, then we can reach a good solution. They fix up the sequence. Order means sequence. And content. Services to be studied and implemented. What are the contents? What we'll read a lot in the next semester on services. Services. What are the services to be included or not? We'll see slowly, and next semester we'll see how the services come into the picture. So they fix up the contents of the services. Who? The architects. Then helps development teams to transition from architectural design to more detailed design. Then these people help. Initially they do the reference architecture. From reference architecture, how the detailed design means the class level design, the class diagram, more detailed design up to the class diagram level. How this type of transition will take place, that they make a plan for it. From reference architecture to the class diagram, and from class diagram to the code. They help. Anyway, this is what they coordinate and coexist. They coordinate with all the team members. As I told, under one architect, there may be several teams. Team A, team B, team C. Do you see? Team A, team B, team C. So the architecture team, they coordinate. They coordinate with the different development team, integration and testing team. They coordinate among each other and coexist with them. They stay with them. They always supervise. What are you doing? Are you moving in the right direction or not? They coexist. Okay? No structural difference between architectural team and other team. There is no difference. The team, whatever the rule, policy is here, the same rule, policies in the development team. So they coexist. They coexist. We are part of you. Any problem, call us. We are there to assist you. Okay? They coexist. Just they focus on higher level issues. Some higher level issues they focus, but still they coexist with them. Not that we are superior, you are inferior. We are part of the whole objective. We have a single mind. The need, did you remember the need? They have a single mind. Okay. They coexist. Then what is the pitfall? Problem क्या, दिक्कतें क्या है? Pitfall. of the team, imbalance of skills. जो 11 स्किल मैंने बताया ना, वो 11 मिलती नहीं दुनिया में, इम्बैलेंस हो जाती है. जरूरत है 11, that 11 skill set, but not available. So कुछ लोग ज्यादा एक्सपर्ट हो जाते हैं कुछ एरिया में, कुछ लोग कम एक्सपर्ट है. सो इट बिकम्स इम्बैलेंस ऑफ द स्किल्स. लेकिन जरूरत है 11, लेकिन मिलती नहीं है. इतना आसान नहीं है लोगों को मिलना. इम्बैलेंस ऑफ स्किल्स, लैक ऑफ सॉफ्टवेयर डेवलपमेंट एक्सपीरियंस. ऐसे लोग हम लोग को रखना पड़ता है कि जिनको एक्सपीरियंस नहीं है उतना. लैक ऑफ डोमेन एक्सपर्टाइज उतना नहीं है. मैं इफ आई टेल टू जितेंद्र गोरा राउरकेला स्टील प्लांट की ब्लास्ट फर्नेस के एक सॉफ्टवेयर बनाओ, he doesn't have an experience. He joins the job but he doesn't have the experience. So domain expertise में लोग मिलते नहीं है. People are not available. Lack of authority, आर्किटेक्ट को उतना अथॉरिटी दी नहीं जाती है. हम लोग का जो क्लासिकल ब्यूरोक्रेटिक कॉन्सेप्ट है उसमें the top level managers, they do not give that much of authority to the architect, जिसका चलते architect is not able to take a decision freely. Team acts as a committee. Team lack of authority के कारण they are not able to implement some committee members होके रह जाता है. Something decision they are not able to take. They lack the authority. Only committee member कुछ discussion करके छोड़ देते हैं, लेकिन not able to take a decision because they don't have the authority. ये बहुत सारा होता है. And बहुत सारा में life in ivory tower, मतलब बहुत ज्यादा ही लोग सपना देख देते हैं. हम लोग ये बना देंगे, वो बना देंगे, ये will do this. So ज्यादा ही सपने, मुंगेरी लाल की हसीन सपने ज्यादा देखते हैं लोग. We can bring do wonders. Life in ivory towers. Then some confusing tools, techniques, methodologies with architecture. They bring certain tools, techniques. LTSA मान लो is a very good tool, but बहुत लोग समझते नहीं है. So उन लोग के लिए it becomes confusing, it becomes hard. So जो लोग के लिए hard है, they are not able to implement. So sometimes hard tools, confusing tools, techniques, methodologies with architectures are implemented by the architect. इंगोले भैया कुछ हाई-फाई टूल बताएंगे जो लोग की तुम लोग को समझ में नहीं आएगा. Then you start complaining, then problems comes up. So there should not be this type of any sort of confusion. Any sort of confusing tools should not be implemented. हाँ. Then procrastination. Procrastination क्या? इंगोले भैया will tell you something to do this. सर आज उतना हो गया, 4 घंटा हो गया, 3 घंटा से ज्यादा, 4 घंटा 1 घंटा ज्यादा हो गया सर, काल कर लेंगे. वो काल आप लोग का नहीं आएगी. Procrastinate, जो the mindset of the people who intend to defer it without completing the job in that moment, they always have the mindset to defer, to do the job later on. ये बहुत सारा प्रॉब्लम पर्टिकुलरली बहुत सारा डेवलपर्स का अंदर में रहता है. सर ये काल कर दे, पक्का सर पक्का, लेकिन वो पक्का कच्चा हो जाती है, होती नहीं है. एंड द इम्प्लीमेंटेशन गेट्स डिलेड. तो ये नहीं, ये होता है, दिखाई जाता है, पिटफॉल है ये टीम में, लेकिन ये नहीं होना मांगता है. लैक ऑफ अथॉरिटी, ये ज्यादा टॉप मैनेजर अथॉरिटी देते नहीं है आर्किटेक्ट को, जो कि देना चाहिए, नहीं देते. सो ये है एक पिटफॉल है, एक ड्रॉबैक है. व्हाट इंसेंटिव्स आर देयर फॉर द ग्रुप लीडर्स, लोगों को कुछ इंसेंटिव देना मांगता है. दे हैव टू बी इन kept in good spirit because they are the leaders. Follow recommendations of architecture team. अगर इंसेंटिव ना दो, if I don't give incentive, then why people will listen to me? So they will only follow the recommendation of the team if some incentives are being given, जो कि नहीं ज्यादातर केस में नहीं मिलती है, नहीं दी जाती है, not being given. Report progress or problems to architecture team, जिसका चलते हैं the report of progress and problems are not being available. Frequently has to exploit authority. Architects are not managers. They are often being told, you are not the manager, you are not having the control with the funds. ये comment उन लोग को सुनना पड़ता है. You are not the manager. We will give you the funds, whatever is available to us. If you demand this much, we won't be able to give you. So ये sentence problem होती है manager, top level manager जो कि पूरी authority देते नहीं है. They don't provide that much funds. Just another team in an organization. You are as good as other teams in the organization. You are no way something special. So this is the sentence. The top level managers, they speak to the architects who do not understand the value of the architect. As a result, the problems are compounded when external architect or architecture team is had. जिसका चलते one team gets demotivated and the top manager brings another team. The problem lies with the management. But as a result, one team is forced to move out and the management is forced to have another team. So again, another team is to be groomed up. So that takes a long time, but this happens with the architect team because they are not being given many times the authority to take certain action. So what is the solution? Must influence based on skills and experience, must communicate. So the architects should have the capability to influence the management, should have the capability to influence the management based on his past skills and experience. And they must communicate with the management, top management, to get certain authority. They must. और एक क्या है? आइवरी टावर, लाइफ इन आइवरी टावर. ज्यादातर लोग सपना में रहते हैं. That I can bring wonders if I get the software in implementation level. My software will be the best. It will have this type of solution, this type of presentation. They always dream a lot. Life in ivory tower. Developers and manager must be aware of architects' team's existence and role. They must be aware. We have certain role to play. We should not dream extra. What is the solution? Team must continuously communicate with rest of the personnel. Team must co-located with the rest of the project personnel. Do not use a team as a retirement home for aging developers. Architecture team must recognize and adjust to organizational realities. They expect a lot from the management. हम लोग इतना बढ़िया काम करके organization को देंगे, so we should be something special. But ये नहीं होना मांगता है. They should recognize and adjust to the organizational reality. Organization की जो reality है उसको they should realize it. Okay. What is there? They should assess their technological base. What is their personal issues, organizational politics, market pressure. अभी कोविड की चलते सारे मार्केट डाउन है. If the architect team will expect a lot from the company won't be able to provide. So what is the market pressure? They should visualize. They should not stay in the ivory tower. So imbalance of skill. मैं पहले ही बोला था कि 50% है communication, rest 50% job of the architect is 10 skill sets. जो कि बंदे मिलते नहीं है, लोग मिलते नहीं है. People are not available. क्यों? Problem, predominant expertise in one एरिया क्रिएट्स इम्बैलेंस. अगर एक एरिया में मैं ज्यादा एक्सपर्ट हूं, दूसरा एरिया में मेरी नॉलेज नहीं है, तो इट क्रिएट्स प्रॉब्लम. मेरी नॉलेज ज्यादा है इन डाटाबेस, इन GUI, in networking, in system, but I don't have any knowledge in other areas, then it's a problem for the team. Imbalance may affect new architecture each. Any new architecture, if at all design, then it creates problem. If at the time of design, communicated, evolve, if at all the skill sets are not available, it gives problem. देन सोल्यूशन क्या है? बैलेंस आर्किटेक्चर टीम चाहिए, एक बैलेंस टीम चाहिए टू प्रोजेक्ट टाइप एंड साइज. कौन सी प्रोजेक्ट एंड कौन सी साइज के लिए, कौन सी प्रॉब्लम डोमेन के लिए, एंड व्हाट टाइप ऑफ पीपल नीडेड फॉर दैट पर्टिकुलर प्रॉब्लम. बैलेंस चाहिए, लेकिन मिलती नहीं है, ट्रूली मिलती नहीं है, वेरी डिफिकल्ट. द कंपनी जस्ट somehow मैनेज बाय गिविंग सफिशिएंट ट्रेनिंग. Confusing tools with architecture. There are certain confusing tools the architect wants to impose on the developers, and it takes time to understand and implement. So what is the problem? There are certain databases which are hard. Very few people have done work on MongoDB or something. A lot of database tools are there. So the architect goes on trying one after another, various database tools, various GUI tools, various case tools. So it gets the developer confused in which area he should be expert, so that his job can be smooth. So that brings confusion. More recently, the culprit is middleware. In the middleware, a lot of emphasis is being given, that is on Corba. That is on Corba. So one has to be expert in Corba. If you are not expert in Corba, then you land in trouble. So this type of different confusing tools give problem. Okay. So solution is, we need to have a very balanced architecture team having knowledge in basic requisite tools. All the tools, my team is not supposed to be expert, but I should have a team having that type of balance. Okay. Then this procrastination. Sir, मैं कल कर दूंगा. I'll do the job tomorrow. Procrastinate. Procrastinators always bring problem for themselves as well as for the team. क्या है problem? Waiting until the team is convinced it is able to make the right decision. Incomplete and changing information yields indecision. Architects' indecision impacts other teams. Domino effect may paralyze entire project. ये क्या है? Domino effect. Domino effect क्या है? Are you aware of it? Anybody? Anybody is aware of domino effect?
Sir, if one thing falls, then the sequence
Yeah.
that preceding
Yeah.
that also falls after that.
Yeah. In your childhood, you were playing with some building blocks. It so happens that if you pull out one block and all the blocks fall, you might have seen in your childhood, your parents used to give you some building blocks, बेटे बनाओ, एक मकान बनाओ. Then धीरे से तुम्हारा छोटा भैया will come and bring out a small block from that, and the whole effort is gone. Everything gets shattered. So that is the domino effect. The effect that brings whole everything into disarray if you pull out one unit from it. So if one person gets one small module delays in development, the whole thing gets deferred. That's the domino effect. whole thing may paralyze the entire project. So it has to be a balanced. So all the team members should not have the disease of procrastination. This is a domino effect. Anyways, what is the solution? Often better to make a decision than suspend the project. You take a decision, don't suspend it. Make educated guesses. When you are making some guesses, do the guess based on certain thought, certain logic, certain pre thought on it. Hum educated. Document rationale for decision. Bring out the document which are really true, rationale. Any sort of document, if I want to keep for taking subsequent decision, it should be truly logical, rational. Document known consequences. Any document I should catch which will bring certain consequence, not false, vague document. Change decision when better alternatives present themselves. Be decisive. Don't procrastinate. Be decisive. Being an effective architect demands rapidly making tactical decisions and living with resulting anxiety. Suboptimal decision based on incomplete information. Any sort of incomplete information leads to suboptimal. If you have incomplete information in your hand, you won't bring out the optimal decision. So it says that be always affirmative, be rational, identify what are the known consequences. Very particular you should be in all your decisions. Okay. So this is the summary of the whole people, role and team. Very good chapter. It is mostly management related, but plays a very vital role because a team is managed by the people only, and they do certain roles and they work in a team. So what is the summary of the chapter? The company designates an architect or assembles architecture team to be creators. They are the creators and proponents of common system goal and vision. Proponent, they propose a common system goal, a goal having common to all the members. They propose a goal or vision for all the members in the team. They are the creator. The architects must be experienced in at least in problem domain and software development. In problem domain, that means ये blast furnace के बारे expert होना मांगता है, या तो पोर्ट के बारे, या तो एयरपोर्ट के बारे, या तो इंगोले भैया की इंडीड job portal के बारे. So the person should have past experience, particular domain, and software development. What type of software needed for job portal? कौन सी सॉफ्टवेयर चाहिए, कौन सी डाटाबेस चाहिए, कौन सी पाइथन या लैंग्वेज चाहिए, what which will work best. He should have that experience. Software architect is a full time job. ये 24 hours job है. ये नहीं कि 8 घंटा में कर लूं उसके बाद खराटे मारूं, ये नहीं. It's a full time because you have to be expert in 11 skill sets. Character of software architecture team should be clearly defined its roles and responsibility. He should be able to understand other members, what are their roles and responsibility. Clearly specify its authority. मेरी authority ये है, that much only you expect. You members, you expect that much. Don't expect too much from me. Do not isolate software architecture team from the rest of the project personnel. So, the architecture team should not be isolated from the other projects of the organization. Don't isolate. They are the main key people. Avoid any pitfall. Pitfall means any drawbacks in the software team. Avoid it. So, this is the summary of the whole chapter. last chapter of the book on software architecture. So, software architecture we read the very first. There is a very good chapter which tells about the 11 characters of the architect, and out of 11 characters, the third one, the communicator, the most important, valuable character he should have. And 10 are also equally important. The most important is communication, that is the 50% of the job. But the team should have a common goal. They should have the need, a single mind. Then only the architect can be able to develop the desired software. Yes, that's all. That's all. All the theoretical portion is over. So now we'll discuss some of the things which we have not yet done. So I hope we should be able to do something. So we'll start with today, and we'll do the job on Thursday, Friday. Friday you have class. On Saturday, then Monday, Tuesday, Thursday, and next Saturday we'll finish up. So we'll finish up everything by 12th of Saturday, if required, or else even we'll see. Some things I had given a story told to whom? Ranveer CSP and CEP Kulkarni. Okay. Earlier I had told pi calculus to Rekaj and Globus grid to, I think, Chotrai, I think, Rautrai, I think, or whom? Globus grid. Yes. So Rautrai, you come first. So Rautrai is the boy who will tell us what is that grid, how does it help, why we are interested to know about its architecture. So Rautrai, you share your slide.
Okay, sir.
Yeah. Be brief, 15 points. Your teacher Ingole Bhaiya is waiting. How good you have done. So you have to satisfy him. In what way this helps as a good topic for your architecture study. So Globus. Globus we read in which chapter? In which chapter? ऋषभ सोनी जा मुंडी से हट गई. ऋषभ सोनी.
Yes, sir.
ग्लोबस सॉफ्टवेयर किसमें कौन सी स्लाइड चैप्टर में हम लोग पढ़े थे? सर पढ़ाई में कहाँ करता हूँ सर, ज्यादा उम्मीद मत कीजिए मेरे से. ये
The chapter 5, sir.
चैप्टर 5 देख रहे हो ना. प्रतीक जसवाल आंसर देता है, ऋषभ सोनी रास्ते में घूमते रहता है. ओके, स्टार्ट.
Yes, sir. So 1 second. I'm sharing, but
सिद्धार्थ.
yes, sir.
Where
1 second.
is Siddharth?
Yes, sir. So I'm sharing, but
Do it.
network issues, sir. So give me 1 minute.
Oof. So many people are waiting for you. Rekaj is waiting for you. Who is waiting? All are in queue. Ranveer is waiting. Kulkarni is waiting. Siddharth, come.
It is not sharing, sir. So 1 second, sir.
Oh, okay. रणवीर आ जाओ. रण में जीत लो. सिद्धार्थ हार गया रण में.
यस सर.
हाँ, रणवीर आ जाओ. सिद्धार्थ हारा हुआ है. तुम्हारा रण में तुम जीतो. यस रणवीर. यस बढ़िया. तुम्हारा पेज नंबर थोड़ा कंस्पिक्यूअस होना मांगता है. ओके
सर
It should be bold. बाबू तुमको सिद्धार्थ पूछेगा पेज नंबर 18 के मैंने 3 किधर है, so it should be very clear. Anyway, सीखो बेटे, सीखो. Okay, सीखो. Okay, करो रणबीर. Okay.
Okay, sir. It is visible, sir.
या very nice, बढ़िया किया. कभी ब्लैक मत करना. Okay, करो. Next, चलो.
Okay, sir. It is the topic is CSP, communicating sequential processes. Okay. So what is this? What is CSP? It is
इसका background white करो. Black is painful to the eye. करो, चेंज करो. सीखो बेटे, सीखो. मैं सिखाने के लिए तुम्हारे पास खड़े हूँ. Yeah. You can make bluish. Yeah. Very nice. करो. It should be appealing to the eye. Okay. अब दूसरों की आंख को don't give problem to others. Okay, बेटे, चलो.
Okay, sir. Okay. So the what is communicating sequential processes? So it is a formal language for describing patterns of interactions in concurrent systems. So
जोर से बोलो.
Okay, sir. It is communicating sequential processes is a formal language for describing patterns of interactions in concurrent systems. Okay, so I will also tell in the next slide about what is formal language, pattern of interactions, concurrency.
Okay.
So the first CSP, it was the term CSP, it was first being used.
You share everything. I ask question to everybody in the exam. So everybody should not hear only. Make a note while Ranbir is telling, others should make a note. I'll ask in the next class. How does it help? CSP, now it helps to describe patterns of interaction in concurrent system. So you please make a note of it, okay? It was developed by a British scientist, C.R. Hoare, in 78. So I asked this type of question in next class. So make a note of it. Don't sit idle. Okay, beta, chalo. Yeah.
Okay, the CSP, the term CSP was first being used by the British computer scientist. His name was C.R. Hoare, that is Charles Anthony Richard Hoare, in 1978. Okay, its key feature is its reliance on non-buffered message. I will also in the next slide discuss about what is non-buffered message. Passing with explicit naming of source and destination processes. So the name of the source and the destination processes has to be defined explicitly. So its source, what is the source process, what is the destination process, it has to be defined explicitly. Okay, it also uses guarded commands to let processes wait for messages coming from different sources. So it uses guarded commands to let processes wait for messages. Okay, so I will discuss about guarded commands also in the next slide. Okay, now first is a non-buffered message, that is non-buffered send and receive. So the non-buffered send, when the process issues a send, the system call does not complete until the message is received by another process. So explicitly we have to define the source and destination process, and then if the process A, suppose process A is sending that request, and then it will block all other system calls until process B gets that that message. So it is, that's why it is also called blocking send. It will block all the system calls until the process B receives it. So in the same way also, it is the process non-buffered receive. When a process issues a receive, the system call does not complete until a message is received by the process. And in the same way, all other system calls will be blocked until that is being received by the process, that destination process. So now guarded commands, we have already seen this in the lab, but I will tell again. See this, there is a guard condition and there is a command list. Here guard is a Boolean expression. Okay. Whenever any guarded commands guard the command list, means no other process will be able to go in the command list without going through this condition. When the condition has to be true, then only the command list will be executed. So here I've used two examples. I have used pseudocode, that is n is less than 10, then only n is equal to n plus 1 will be executed. And same for the I also. If I is greater than 2, then I is equal to I minus 2 will be executed. So here n is less than 10 and I less than I greater than 2 are the guarded commands. Now so formal languages. Now, what is formal languages? The set of strings, all of which are chosen from some alphabet with notations, is known as formal language. Now, the alphabet formal language consists of symbols, letters, that is A, B, C, and symbols is at the rate of hash, that all that symbols, and tokens that concatenate, and that concatenation, after the concatenation they will become strings of the and that whole set will be the formal language. In mathematics also we have seen propositional logic or propositional calculus forms the formal language. For example, I have taken this example to make clear about the formal languages. I have taken this sentence: if the day is Saturday or Sunday, then Tom's office is closed. So there are I have taken three notations: A, B, and C. A means the day is Saturday, B means the day is Sunday, and C means Tom's office is closed. So I have used here or. So or for this sentence, sorry, for this sentence, the formal language will be A or B implies C. Means the day is Saturday or Sunday, then Tom's office is closed. Is entire this sentence is defined using this formal language. Now, patterns of interactions. When two processes are brought together to evolve concurrently, the usual intention is that they will interact with each other. Okay, for example, in a football team, they are all 11 players in a team, and they have to play in a like a team. Means they have to interact with each other, and it has to be in a particular pattern. So if here also the processes has to interact in a system, they have to interact with each other in a particular pattern. So suppose process A is executing, then B is executing, then C is executing, and again A comes. So they have to maintain this cycle in a particular pattern: A, B, and C. They do not break this pattern. Suppose B, A, C, not like that. If A, B, C is going on, then A, B, C. That is particular pattern. So that is pattern of interactions. Now, concurrency. Concurrency is the decomposability property of a program, algorithm, or problem into order independent or partially ordered components or units. This means, what this means? This means that even if the concurrent units of the program are executed out of order or in partial order, the final outcome will remain the same. Okay. This allows for parallel execution of the concurrent units, which can significantly improve overall speed of the execution in multiprocessor and multi-core systems. So the overall outcome should remain same if they are executed in the concurrent system. Now, so for next 2 to 3 slides, I will take this example to explain you about alphabet, recursion, and choice, which is being used in CSP. So what is vending machine? We all know about this. The machine which takes the input a coin and returns the appropriate chocolate or snack to the customer. So it takes coin, the input is coin, and the output may be chocolate or scan, that is up to the customer. So this example vending machine and its variations I will take to explain what is alphabet, what is recursion, and what is choice in CSP. Okay, yeah, alphabet. So example here is vending machine for chocolate. So these are the two alphabets: VMS, that is vending machine server, and VMC, that is vending machine customer. So what are the events associated with VMS? That is coin and chocolate. Means it only knows about the coin and chocolate. Input is coin and the output is chocolate. And VMC, what are the customers know? That input 1p, p is penny, input 1 penny, input 2 penny, and means coin. Then small, large. So what is small and large? Means small chocolate for 1 penny and large chocolate for 2. output 1 penny. Why this output? Because if the vending machine is empty, then it will simply return that coin and saying that there is no chocolate available. So all these in the curly brackets are events, and VMS and VMC are the alphabets. Okay. Now recursion. We have already learned about. So I'm here taking the example vending machine that serves as many chocolates as required. Okay, in the to explain recursion, we have all seen that printing machine means there may be 10 pages. It takes 10 pages and prints out in a sequence. Means takes one page, print it out, and then takes another page and print it out like this. All the 10 pages. That is a kind of recursion only. Okay, so here it will take. This is a type of vending machine I have taken where it will take coins in that order. In the printing machine, that pages are being taken by the printer, it will take the coins one by one, and output will be chocolate. So here it will take coin, then chocolate, and again back to VMS, again coin, chocolate, and back to VMS. Okay, now this is an alternative equation. The formal definition can be like this. This U is defining is a symbol for recursion. So it's coin chocolate and then coin X, chocolate X. It will stop when there will be no coin. When there will be no coin, it will not take any input and it will stop. That's the time when the recursion will stop. Okay. Now choice. Here W, X, Y, and Z are distinct events. Then choice is denoted by W to X, then Y to Z. This vertical bar means that you can only consider one of them. It means either W to X or Y to Z. We cannot consider both of them. We cannot choose both of them. That is, here I'm taking, for explaining choice, I'm taking the example, a machine which offers a choice for the change of 5 penny coin. I want a change for 5 penny coins in 1 or 2 pennies. Okay, so the input will be 5 penny. It has three options, three choices. It may 5 penny coins. It may be that all the 5 outputs I get in 1 penny. That is also possible. Then 3 1 penny and 1 2 penny, and 1 1 penny and 2 2 penny. I made it. So any one choice, that server, that vending machine server can choose to appropriately for this action for giving out the coins.
So sir is not here, right?
Hello.
Sir is not here. रुक जा, सर को आने दे.
लेट हो जाएगी भाई.
Hello, Ranveer.
हाँ. Hello.
हाँ,
Hello.
Hello.
हाँ.
Hello.
Hello, Ranveer. You can continue.
Okay.
अच्छा इनको ले सर is here. Okay.
Okay, choice is clear now. I'm going to. Okay, one more example. One more example I am taking to discuss about all those CSP. How CSP can be made for any real life problem or any problem. Okay, I am taking the Dining Philosopher's problem, and I am coding it in CSP. Okay, there are 5 philosophers. You can also see in this picture P0 to P4. Okay, they are sitting in circular dining table with a ball in front and a fork in their left. Means the left side fork is their own fork, but they need both the forks in both of their hands to eat. Okay, so the actions are fill I dot sit, then back to fill I, then I stands, back to fill I. We can pick the fork. The dot I means it's left fork. Okay, and then this I have taken because that plus that modulo sign is not available in the keyboard. So I have also defined here that this sign means that addition modulo 5. So what this means, I and this addition modulo 5 with 1. It means that the fork of the right neighbors of any ith philosopher, right hand neighbor of the ith philosopher. Okay, it will take its fork. Its fork means that right side's philosophers left fork it will take. Means the ith philosopher's right fork it will that will be same. Okay, so in the both the hands, and then he can also eat. If he's not eating, then what the philosophers do? They generally think. So he will be thinking. Okay. So this is the code for Dynamic Philosopher's problem in CSP. Okay. So we have discussed about the Wright and Weave's architecture in already in the class. So I'm not going. I will do go through these two slides quickly. Okay. Wright is an early architectural description language. Wright is focused on checking component interactions through their interfaces. Means there are components and their interactions. It deals with the interactions. As I have already
Yeah, Ranveer, just don't copy these type of sentences from the text. In a slide, you have to write only the bullets, the points, not the text. ये तो सारे किताब में है, गूगल भाई को बोलने से तो सारे दे देगा. इसमें आपकी क्या माने दिमाग कहाँ आप दिखा रहे हो? Only the points, important points. Those are to be shown in any sort of presentation, not copy paste करके आप slide दिखा दोगे. ये आपकी negative point आएगी. You are not supposed to copy and paste here in the slide. Only the important point, the bullets only. Only the bullet. ये
Yes.
bullet लिखो और उसको explain करो. सीखो बाबू, सीखो. Okay, go ahead. I won't like to see anybody this type of copy paste business. Okay, go ahead.
Okay, sir.
Hmm.
Okay, right specifications can be translated into CSP and then analyzed with a as a CSP analysis tool, which is FDR, that is failures, divergence, refinement. These analysis can determine if connected interfaces are compatible and whether the system will deadlock. So it also checks about the deadlock. It analyzes about the deadlock, that CSP. Wright has the ability to specify stylistic constraints as predicates over instances. Okay, now weaves.
It is also used in weaves also.
Yes, sir,
in
both Wright and weaves.
Both right and weaves. Okay.
Wright and weaves architecture. So weaves architecture. It is a domain and style specific ADL, that is architectural description language. Now weaves is used to model systems of communicating small grain tool fragments that process objects of data. Now weaves diagram do not capture the protocol or kinds of data that flow across component boundaries. Now this could be rectified through a more formal language specification, that is CSP. So it also uses CSP. Wright and weaves both uses CSP. Lunar lander example has already been taken in the class and explained, so I am not taking that example. I am taking another example. It is secure print server. So what is this? What is the secure print server? So the personal is employees of a company uses a group of printers to print their documents. Okay, they have to print something, then they will use the printers to print it. Now, the company management requires a secure printing system that protects document confidentiality. Means they need a particular type of printer or a particular set of printers which they want to print secret documents. In the next slide, I will make you see that figure. It will be more clear. Now, documents to be printed can be directed to one of two printers located at different rooms. Now the printers are managed by a common print server. Okay. So there will be two printers, public and secret. Public can be printed by anyone, and only the authorized user can print it from the secret printer. Clients who are the
आप
users.
राइट हैंड साइड में एक पिक्चर डिस्प्ले करना चाहिए था.
Sir, picture is a little
पिक्चर एक
big.
हमेशा एनी स्लाइड की दो भाग कर दो. लेफ्ट हैंड कॉलम में टेक्स्ट बुलेट में रहेगी एंड राइट हैंड साइड में पिक्चर, सो दैट इट बिकम्स मोर इंटरेस्टिंग.
Yes, sir, but picture was little big, so
दो
I
थप्पड़ बॉट कहीं नहीं होता है, जहां दिल जहां दिमाग वहां सब कुछ आगे जाएगी. एवरीथिंग यू कैन डू. थोड़ी सी सोच अगर लगाओगे, थोड़ी सी. ओके, करो, सीखो बाबू, सीखो. ओके.
so this is the picture for that secure print server. This is UA, that is ordinary user. It can go to that print P, then request P. This is print server, and this is that public printer, that A, and printer B is the secret printer. That means only that it will only print that is secret printer will only print that confidential document, which is from the authorized user only, and any other user can only print through this public printer. So I'm taking this example, and there is a print P port, then request port request P port. P means this public, and request S port for secret printer, and print S. One more thing, authorized user can also print through the public printer. If the document is not confidential, then can also print through this public printer. Okay. So I will design this using that CSP, and this is so there are security levels: public, secret, ordering is public, clearance list. Now component client, security level. Uh, client means that users, ordinary users, or that authorized user. Okay, print port, print P, request X dash, it will go to print P, means that public printer, and print S means the secret, then request X secret, it will go to print S. And this computation, this in this code, CSP code, print P dot request X dash, then back to computation, and it is kind of recursion only. If the printer is public, means the document is to be printed is public, then it print P, then request X dash, then computation. And if that back to computation, if the secret document has to be printed, then it will go to print S, then X secret, then back to computation. And the next component is printer. That port is request, then it's receive, and the computation, it will receive and it will request it's do print and back to computation. So this is printer, and then next is print server, that middle picture, print server. That ports are request P, request S, output P, output S. Request P, request X, it will go to request P, means requesting the public printer to print. Then request X, requesting the secret printer to print. Output P, print X, then output P, output from the public printer, and output S, output from the that is secret printer. Then computation, it's computation. Request P, request X, output P, that is public, print X, then back to computation. And if the secret, then request S, request X, then output S, print X, back to computation. If the secret is secret document is printed. Now print connector. There are connectors. Print that is print connector. So role is client P, then request X client P. Role is server P, request server P, that is public. Now there will be glue. So client P dot request X, then server P dot request X, then back to glue. So this is the end of that. And in this is configuration, means what are the abbreviations we have used in that diagram. This diagram, that is UA, UB, and then con 1, 2, 3, and this request and all that. C print P, C print S, printer A, printer B. All what is all this? Here it is written. UA is the client, then PS is print server, secure printer. Public printer is also printer. Then con 1, 2, 3 are print connectors, also print C printers and all those. Okay, UA is everyone, means not the authorized user. Everyone else comes under UA, and UB is authorized. Then UB dot print, it is everyone. So it after that it also talks about the attachments. Means where the connectors are attached. UA dot print P is attached to con1 dot client p, and same way it enrolls as per the diagram. Okay. Now, why CSP is used in Write and Weave's architecture? So the main thing to notice about this specification is the detailed set of formal specifications of behavior. The CSP formalism semantically sound well and is well documented. It means it is well documented and has a steep learning curve as compared to the programming language. Means learning is more as compared to the programming language, and also easy to understand. Now, the value of these specifications is that the properties such as freedom from deadlock can be analyzed. So if there is deadlock or not, it can be analyzed easily, which is difficult in case of any programming language. Okay. So the references are Combinated Sequential Processes book by C.A.R. Hoare and the Software Architecture book by Richard N. Taylor. Okay. Thank you.
Okay. Okay. So this is a formal language tool. It's a formal language. Formal language, why it is being used? It is used to validate something, some assumptions. Our whole thing proceeds with certain assumption. You saw certain one page only the English write-up of the bank consortium. From that one page, you want to develop a full-fledged software for the whole globe, for the whole world. So you are assuming and then proceeding. You are assuming and proceeding. So while assuming and proceeding, there is every chance that there may be certain error in our assumption. So there is every chance that certain problem may come up, certain deadlocks may come up, because we are proceeding with certain assumption that if this thing will be there, then this thing will happen. So to verify any sort of assumption, we take help of this type of formal language. So it validates whether there is any blockage or not, deadlock is there or not. So Ranveer is sent to everybody and also to
Okay, sir.
me as well as and to Debabaya and to Ingolebaya.
Okay,
A small
sir.
question will ask on dining philosopher. You have to make the model for the dining philosopher or this printer problem. Small question, my dear otherwise. Practice it. What Ranveer told, nobody asked him anything. I am very unhappy. You have to ask him. He is not telling for himself or for me. Yeah, he is telling for you. So you have to ask him. Hello, Ranveer. I
Yes,
want a little bit more explanation. Ask him. Don't sleep. Don't sleep. Okay? Okay. If you are not asking, I won't also go on changing you. I won't. So then is CP by no Siddharth. Siddharth, come. Siddharth,
Yes, sir.
come.
So visible, sir. Sir, is visible, sir? PPT?
Yeah, visible.
Yes, sir. So, okay. So, what is Globus? So, Globus is an open source toolkit, is an application, and it is basically used for grid computing. So, what are the other services that is used in Globus? Now, it is used for resource management, like a bunch of like there is a given task, and a bunch of computers are used to solve that one task. So there we need to share the resources that will be used for that task. So hence Glovers is used for those kind of things. So it helps in resource management, finding the services and all. So it also hold tools for building the web services. It has some powerful security prerequisites for authentication and authorization. Means it provides security on our applications, and also it provides implementation of some standards like in OGSA. Now what is OGSA? uh, OGSA is basically it is Open Grid Service Architecture. We'll see about OGSA later, and then there's Open Grid Service Infrastructure (OGSI), then Web Service Resource Framework (WSRF). So these kind of protocols have been implemented by the Globus. Now, architecture of Globus. So, the right side diagram shows the architecture of Globus, in where the application layer sits at the top, and using the third-party middleware software, it communicates with the protocols such as GRAM, that is Resource Management, MDS, and Grid Data Management. Now, what are these protocols? So GRAM is used to handle placement, provisioning, and lifetime management of jobs. So it is used to allocate the resource, and it is used to manage the resource for carrying out a certain task. Then comes MDS. MDS is basically a grid information service. Means it is used to share the information between the computers in the grid. So and there is grid data management, where the data has been transferred from one component to another component. So these protocols are also ensured by the GSI security layer. So this security layer is used to provide the public key encryption for the data that has been handled, the informations and all the resources. These are all secured through the security layer, and all this architecture sits above the resources and the local servers that will be used. Then we have the four components that is used in the Globus. One second. Okay, so so now we will see the components of the Globus. These are the resource management, information services, security services, and data management and data movement and management. So first comes about resource management. So the work of this component is to monitor the jobs, to create the jobs, to execute the jobs, to change the signal statements from if the signal state changes. It means that on a certain input, if we are at single state, and at a certain input, if we give a certain input, then what will be the next state, what will be the next job that will be carried out. So this is the job of the resource management component. And then comes information services. It provides information such as the IP address of the computer, the OS version, the network bandwidth, and the latency protocols, etc. All these informations are required while doing the between the communication between the computers in the grid. Then comes the security services. As I said, it is used for creating private and public keys, certificate issuance, authentications. Means all the jobs that will be carried out in the architecture should be secured and should be authenticated. So for that service, security services comes into play. And finally, that is data movement and management, where the data movements are handled, are managed, and the data manipulation such as the replication, updation, all these kind of jobs have been handled by this component. Now let's come to grid architecture. Like, what is this grid architecture? So it is basically an architecture based on the processor. Means processor has to do this in the processor. It's implemented this architecture. So the job here is to combine computer resources from various domains to reach a main objective. That means, let we have a task A. So that task is a very big task. Means that task cannot be carried out in a single computer. So what is done, that that task has been subdivided, that task has been distributed to many single independent jobs, and those jobs are assigned to different various other computers. So then all other computers they solve this task, and then those tasks are integrated at that main computer. So basically this is known as the grid architecture, and this functioning is known as grid computing, and this grid computing is based on the grid architecture. So multiple computers working on a single task to reach at the goal, as I said, and it has the capability of processing large volume of information. So as I said, like, a computer also has a limit, so it can work till a limit. So if we have a process, if we have a task that requires more than one computer's capability, so in that case we use the grid architecture or grid computing. Hence it is said that grid and the computers or the jobs based on the grid architecture is said to function like a supercomputer, because supercomputer is that only. It is used as a input and output of many sub machines. Then comes the problem solving methodology used in grid architecture. So as I said,
Siddharth, just
yes sir.
your fonts are very small. It's painful to the eye. Can you please increase
Okay,
the
sir.
font size?
Okay sir. Okay sir.
You think always for the persons who are using spec. So can you increase the font size? Yeah, in all the slides also think about it, right? Can you also further increase? Yeah. What
Yes,
is
sir.
the font size now? What is the font size?
So 26, sir.
Okay. So keep 24, 26, something like that all the time, okay?
Okay, sir. Okay, sir.
Okay. 24 is the standard.
Okay, sir.
Okay.
Thank you, sir.
Okay, fine.
Uh,
Go ahead.
now let's come to the problem solving methodology in the grid architecture. So as I said, there is a big complicated problem that needs to be solved. So that problem is first subdivided into smaller sub problems, and the important thing in here is those sub problems should be independent of each other. Then those sub problems are assigned to each computers, or in the architecture it is known as nodes. So those computers will then solve those single sub problems, and then all the solved problems will be integrated as they're subdivided. So this is the problem solving methodology in the grid architecture. Now let's come to the some basic components in the architecture. So there are three things basically. There is a control node, also known as a master node, and there are just nodes, and there is a connectors. Control node is the one that is the administrator of the whole job. So that node, that basically the main task is assigned to that node. So all the subdividing and the integration process has been carried out by the control node. And then comes the components or the nodes. So these are the nodes that participate in the network for the problem solving process. So also these components are divided into two further types. Those are provider component and those are user component. Provider component, as the name suggests, these are the components who provides their resource. So they let other computers or other components in the network to use their resources, and the user component, they uses the resources provided by the providers. And finally there is a connector. So connectors are used for information passing, either data or resource, among the computers or the modules in the network. So connectors, all the data transfer, all the securities services enabled, everything is done through the connectors. Then we'll come to an example. So right diagram shows us like how there is the architecture. Let me increase the font. 1 second. Then there comes, okay, the example. So this is the diagram. So there is a control node and all the other nodes, and you can notice that all those nodes are independent, hence they are using different operating system. They are not using the same operating systems. So they all the since they handle individual tasks, they handle individual jobs. So they have been operated with different operating systems. Like some node are using Kali, some node are using Windows, some Ubuntu, some Debian, and hence. So all those nodes, they are assigned some tasks, they carry out those tasks, and then finally they integrate all their jobs at the control node. Okay, now finally so this is all about the grid computing and how grid architecture is implemented by grid computing, and how Globus, the one that sits above all, uses these kind of services. Now finally we'll talk about one last thing, that is OGSA, Open Grid Services Architecture. Now what is it? It basically defines a service oriented architecture for an environment of grid computing. In a grid computing environment, how this service oriented architecture is carried out, this OGSA protocol defines that. Now it defines the way in which computer is shared among diverse components of large heterogeneous grid system. Why heterogeneous? Because all the computers can operate on different operating system, can operate on different applications and everything, and the task will still be carried out. So that's why it is known as heterogeneous grid system. Then it applies to hardwares, platforms, and softwares in standards based grid computing. Means OGSA protocol lets a network be a grid computing system. So and also it supports grid requirements. So what is the grid requirements? Grid requirement says that there should be the strict rule of solving a problem using the grid problem solving methodology. There should be proper utilization of resources, that there should be proper utilizations of security services. And how these all are enabled? These are all are enabled through the Globus application source. So that's all. Thank you.
Okay. So this is mostly a cloud-based operation, right? Yeah.
Yes, sir.
Yeah. It's a SOA service architecture. You will be reading a lot on the SOA. So keep it in mind. I will ask you next semester, I may be teaching that, how you can extend the SOA architecture there. So you catch hold of your good friend from today and start working. Even Ye is there, Ingole Bhaiya is there to guide you. How SOA architecture you can extend it for a particular purpose. For a particular purpose. It's a very good area of research and grid computing. A lot of faculties in our department work in this area. So it's a very good area. You can extend in this area. Okay.
So should I cancel the share?
Yeah. So next is CP. Kulkarni, aa jao.
Yes, sir.
Kulkarni.
Yes, sir.
Yeah. Yeah. Other boys keep note of it and ask Siddharth to share his slides to you. So that a small question how SOA comes into the picture. Definitely have the different layers of SOA. What are the different layers of SOA? Nobody asked him. I'll
Sir,
definitely ask you. Yeah.
Is it visible, sir? Yes.
Yeah, it's visible. Yeah. So people, you boys keep note of it, how SOA works in grid. Okay. Complex event processing. Okay. It is also there in chapter 5 or chapter 7? Or which chapter? You have read it in CP?
Sir, it is in modeling chapter, sir. Modeling.
Okay. How that modeling helps, you tell. Okay. Let us hear from.
Yes. Sir,
Kulkarni.
is the slideshow visible? Yes.
Yeah. Please go ahead. Yeah.
Okay, so the topic is complex event processing. It is called CEP. So first we'll see what is event processing. Event processing is a method of tracking and analyzing streams of data about different events that are happening or taking place and deriving conclusion from them. So we have different events that takes place in the system. So we track them and analyze them and derive different conclusions from them. Now we look at what is complex event processing. So complex event processing consists of set of concepts and techniques for processing real-time events and extracting information from those events. So it is a technology surrounding circumstances of that event. So 1 minute. So the CEP was developed at the Stanford University between 1989 and 95 by Professor David Lackman to analyze event-driven simulations of distributed system architectures. Now, how the CEP do the processing of events? So it uses a various number of techniques. Some of the techniques are given here, like event pattern detection. Event pattern detection, we can take an example like suppose you have a Google account and you log in into your Google account, and then you get login into your Google account from a new device or from a new browser, and this event now triggers various events in your system, in the system of Google, like it sends an email for verification. Is the person you only who has logged in, and then again it then you respond by clicking on the event saying that yes, it is me, which again in turn makes a new event, takes a new event to happen, makes a new event to happen, and hence it is now recognized that the person is you only. Then next time then such a event takes place, then that pattern of events can be matched and can be considered as a uh, valid request. So now the second is event abstraction. Event abstraction means we can provide abstractions to events, like when we have very small number of events taking place, so we can convert that event into a big event to avoid the complexity of the events in the events. Then we have event filtering. So we can filter the events on various parameters like time and types. Again, we have construction of hierarchies of events. So construction of hierarchies of events, like suppose we have in the operating systems, we have events that are taking place at the hardware level, or we also have the events that take place at the kernel level, and the events that take place at the user level or the application level. So these are the different levels we can have in a operating system. Such kind of hierarchies we have to construct between the events that we are studying. Then we have detecting relationship between the events. So how the events are related with each other is what we have to see, and is what CEP helps us in getting from the events, from analyzing the events. Now CEP is used in various commercial applications, and it is used in various places like business management, algorithmic trading, financial services, IoT, etc. So now we will look at an example of what is a complex event. So a complex event is event where you have many events taking place at random. So this figure shows an instance of events happening for a particular philosopher in a dining philosopher problem. So this is a particular instance. So when you have this one philosopher who actually gets hungry, and then various events takes place with this one event hungry of getting hungry of the philosopher. So he requests the sticks, the right stick and the left side stick. Now in this case what has happened is we when the philosopher is requesting for the shift, it is found out that the chopstick on the right of the philosopher is busy with the other philosopher. So again, these events are also taking place. So the other philosopher is eating, then he puts down the sticks, and he then frees the sticks, and that stick is released to get it for this philosopher who is hungry now. So this is again events that are triggered when we are having this hungry event taking place in this particular philosopher. So all these rectangle box that are shown are the events that are taking place, and the arrows that are shown are the direction of the events. So all the sequence of these events that are taking place by a small event by starting of a small events together can be called as a complex events. When we have more number of philosophers, then it gets more and more complex and hence difficult to manage. Now we will see how CEP is useful in terms of software architecture, how it is useful for us in software architecture. So we look at the Rapidae architecture definition description language, the ADL. So what is Rapidae? Rapidae is an event-driven modeling and simulation language and is based on the CEP. So it is developed to specify and explore dynamic properties of a system, components that communicate using events. So it is been designed or developed to explore the dynamic properties of a system which has a complex events taking place in it. So it is accompanied with a tool that allows user to execute the architecture description so as to simulate operation of described system. When we simulate a model using a Rapidae, you get the output as a cloud of events partially ordered by time and its dependency among those events. So organization of events into partially ordered sets. This is the most powerful tool that Rapidae has. What it does is it organizes the events into partially ordered sets or POSET. So RapidA components were concurrently emitting and responding to the events. These are causal relationships between some events. The causal relationships or the dependencies between event A and event B in RapidA exist only when the following things are true. So what are the scenarios? Like when A and B are generated by the same process, then A and B are dependent. When a process is triggered by A and generates B, or a process generates A and then assigns to a variable V, another process reads V and then generates B. Again, if A triggers connection that generates B, then and which is preceded by A precedes C, which is preceded by B. This is transitive closure. Now, if we closely observe all these uh, rules which state the dependencies between A and B, then we realize that it is actually showing the properties of a partial order sets that we studied in set theory. The properties of transitivity, reflexivity, and reflexivity, and okay. So this is partial order sets of events. So this is how the in figure the partial order sets of events is depicted. The left portion of the figure shows a raw event stream over time, which are temporarily ordered from time 0 to t4, and the right portion shows the events, the casual orderings or the dependencies of the events. Here there are two partial order sequences. So we have A, B, D, and we have this C and E. That is a partial order sequence, two partial order sequence that we have. So these are called the partial order sequences because not all the events in this raw stream are dependent to one another. Like if you can see ABC and D are only related. So even if the event C would have occurred before the event B, then also there was no problem because it has no dependency with the event B. So it can even occur before B over here. Now let us look at how is RapidA syntax. So this is an example that we have seen. This is a two-player lunar lander architecture in RapidA. I have taken this example because it is easy to explain all the important functions of RapidA with this example. So RapidA syntax is a textual notation resembling a programming language. It is used to define the components in terms of interfaces and their operations. Each interface has events that it can receive or send out. Now, as you can see in this code, so data store is a component, and it is having an in event, that is the receiving event, that is set values, and a outgoing event, a send out event, that is notify new values. Similarly, even calculation component has similar in and out events. So RapidA description also has behavioral info, which is used with the application structure to generate the event graphs. So whatever the event graphs that we saw here, that can be generated with the use of the behavioral info of every component that is described in the RapidA description. Now here you can see the behavior has been shown for the calculation component, and what it does is it takes the set burn rate from the player and then calculates the new set and then triggers this event called do set values. So this is the behavior of this component calculation. It is now RapidA is optimized for operating on concurrent applications where multiple threads of control can interact. That is why we have writing this RapidA architecture description for a two-player lunar lander game. So now we are continuing with the code itself. So we'll see how the code or the rapid description uh, we can see how the rapid description is working. So the player starts by sending an updated burn rate as its first move of the game. As you can see, the player one, it starts do set burn rate, and then it gives it to the calculation component, that is the C. So P1 and P2 are the player components, C is the calculation, and D is the data store. Then the player waits for the display to be updated with new status before making the next move. So it waits. Then the calculation components wait for the set burn rate events, which which it is getting from the player component here. Then when it receives one, it will fire its internal event called calculate new state, as you can see here in the code. So calculate new state, and that event is fire, and fire a do set values event for the data store component. So the data store component then updates the game state when it receives the do set value event from the calculation component, and then the data store updates the game state and fires notify new state event, which causes the player display to be updated. And once the player's display is updated, now the player is ready to play the next move. All these things happen in a very fast and concurrent way. So it has to happen fast so that the player does not feel any lag in the game. So now we will see, after we run the Rapidus simulator on the Rapidus syntax that we have generated, on the Rapidus code that we have written. So we get a graph like that, the one which is shown here in the right. So this graph is generated as we provide this the code to the Rapidus simulator. As one of the Rapidus primary focus area is concurrent architecture, it attempts to trigger simultaneous processing by loading the simulations with a number of start events at the beginning, as you can see in the figure. So there are 5 start events in the simulation that we are looking at. So these 2 are for the player 1 and these 3 are for the player 2. So this helps Rapide to provide the simultaneous processing in the system. Again, by observing the graph, we can see that 2 pathways are intermingled with each other. Requests are getting intermingled when we are having 2 players. So as you can see, the event calculate new state is been triggered by is been intermingled by the start event of the player 2 and also the do set burn rate of the player 1. So these things are creating confusion. So since we have not written any locking or transaction support in the design that we have written, because of that this thing is happening, that is there is confusion in which event has to trigger the next event. So there is confusion in it. So now, but these bugs are known to us. These bugs that we can see that there is a problem in the concurrency of the game that we are developing are known to us because of the Rapide graphs, which uses various CEP techniques to generate them. So it is because of the Rapide graph we are able to generate this, and we can now develop some concurrency control mechanism to make our application better. So all these, if we have not used this Rapide architecture description language and we would have just gone for the development and the implementation of the software or of the system, then this thing would have been discovered late in the implementation stage or at the testing phase of the development, which would have led to a lot of cost to fix the error. So now this is this is how it is helpful when we make a architecture description of our software project, and has we can say that Rapide is useful for us to design a software, and this because of the various CEP techniques of processing that it is using, processing events that it is using, which helps us to make our software better. Thank you.
Okay. CEP, what are the comparable? What are the comparable other techniques along with CEP? What are the related techniques available in the literature? That these are also the similar category of techniques which can be applied for this purpose. Have you checked?
Related techniques, sir.
Yeah, similar category, which can be equally be helpful.
So Rapide model is using it.
No, Rapide model is using it. I'm talking about CEP.
CEP.
Yeah, similar category of techniques. Rapide is a ADL,
Description.
right?
It is a
It is
description
language.
Yes.
ADL, architecture description.
Yes.
Rapid takes help of CEP. So what are the similar category of other techniques at par with CEP which also help? You check it and tell in the next class, okay?
Okay.
Always, this is called the survey of literature. Whenever you are this modeling language, CSP, your good friend told Ranveer, he should first tell these are the similar category of modeling tools, validating tools. So you should also tell these are the similar category of techniques. Out of these similar category of techniques, this technique is special because this character, these regions, we claim that CEP is special, better than others.
Yes.
Always these things should be at the introduction. These are the similar category of techniques. So likewise, the CSP, he should tell these are the similar category of validating tools. Validating tools, they validate any assumption. So you should also tell what are the similar category of tools. So Ranveer and Kulkarni, you have to tell in the next class. Okay, check it.
Shubham.
Okay, sir. Yes.
Yeah.
So Shubham Kulkarni.
Yes.
Yeah, Subham.
Are
Yeah.
there any examples like where it is used in the industry? CEP.
Yes. I have shown like where it is used. It is used in various commercial applications like business management and algorithmic trading, or financial service, or even in IoT you can use it, like when we are designing some IoT application. So we have to manage the events that are taking place in that IoT sensor, so that the events that happen in the environment of that sensor can be analyzed to give an gives something analyzation of that events to the user, so that it will be helpful. The sensor could be helpful for the user.
Your Subham Bhaiya works in financial services. Okay, so he is interested in financial services. So you check
Okay.
it and tell him on Thursday. So
Okay.
how you check any paper, how CP helps in financial services. So
Okay,
he
sir.
can work with you when you are free, so that
Yes.
some more work you can do using CSP or any related tool,
Okay,
any
sir.
related technique for financial services. Okay, he is working in that area in this year. Okay.
Yes. Sir, as this PPT was just for software architecture, so I just did the application of software.
No, that's good. You have done it. I am happy. I am happy that you are showing these are the different application areas: business management, algorithm trading, financial. So Subham Bhaiya got interested. Just you see, it depends
Yes.
on individual person. individual person, he got interested in this word, financial services. He is working in that. So, if you have gone through this sentence, then you have to go deeper into it. Anybody can ask, how does it help in business management? How does it help in algorithmic trading? How does it help in financial services? How does it help in IoT? So likewise, so this is the research. This is the research. You go deep into any topic. CP, then what are the other related topics? Which one works better? Where CP fails? By this, you slowly enter into the research domain. Slowly. Okay? Okay. So it is 604. We'll close it down. Right, Ingole?
Yes, sir.
Yeah, we'll close it down. It is 604. It is already late. Okay. So we'll have the lab tomorrow. And tomorrow we are going to have the last lab. I think they will do something more in Petrinet. Is it, Subham?
Yes, sir. Yes, sir. We will see
Ah.
dining philosopher problem.
Dining philosopher problem, you try hard. He has shown something, CSP, he has shown. Yeah, Ranveer, can you download any tool for CSP to prove your, to display your dining philosopher problem? Any tool? You try. Okay? You try. Tonight you try. And you will do this dining philosopher problem with 5 philosophers. Tomorrow first. Then we'll have another tool called JED. How, like this CSP, that is another validating tool. As we saw the different guard conditions in Petrinet, the same things we will use in JED, and we will try to validate. Petrinet is some sort of display. You are displaying that and also narrating. It's a depiction as well as a narration. Any sort of, that's a visualization tool. So visualization has got 2 parts. One, it depicts by picture, and another part is narrates. It narrates. But in JED, you go through a little bit today, and tomorrow we will see how it helps to check the syntax, how it helps to check the different syntax of the algorithms. Okay? Okay, so we will close down. Subham Ingole, you send the link of JED to everybody, right?
Yes, sir. Yes, sir.
Okay, take the attendance and I'm quitting. And you send me the attendance, okay? Okay. Okay. Bye, children. Bye, students. Bye. Bye. We are meeting tomorrow at 9 o'clock. Okay. Bye. Bye. Bye.
So, Andrila Shah,
Yes, sir.
Akshay Kumar, Chandrakant Kumar,
Present, sir.
who Chandrakant or Akshay?
Present, sir. Present, sir.
Oh, okay. Somshekar, Rishabh,
Present, sir. Present, sir.
yeah. Rishabh, Jitendra,
Yes, sir.
Mahendra Kumar,
Sir, present, sir. Hello.
Nir-
Sir, Mahesh Sharma is present.
yeah, Mahendra Sharma is present. Nirmal,
Yes, sir.
Pratik,
Present, sir. Present.
then Rahul.
Sir, Somshekar, present, sir.
Yeah, I'm RQ present.
Okay.
Then Rakesh Kumar.
Yes, sir. Rakesh Kumar present.
Yeah. Yeah, Rahul Sahu is present. Rakesh Kumar present. Ranveer Singh.
Ranveer present, sir.
Yes. Then Shubham. Shubham is present. And Siddharth.
Present, sir.
Okay. Okay, so you can leave the class.
Sir, I got removed at the last moment. I don't know
Okay.
whether
Who, Srilekha or
yes, Sri Lanka.
okay. Srilekha. Okay. Okay, I mark you present. So you can leave the
Thank you,
class.
sir.